Thank you, all of us. Yeah, I will mainly describe a couple of missions that are based on small sats that we recently implemented in Italy, and that are quite relevant to the topic of moon exploration, because they are the first spacecraft that in Italy we prepare for go beyond the Earth orbits and towards the moon and also beyond. The two missions are named Argomon and LiChaCube. And I also mentioning the LiChaCubers, which is basically the colleagues that supported the initiatives. Well, you are probably aware how the CubeSats are changed already. The paradigm of space exploration, they are a really important asset to contribute and to complement the traditionally sized mission. And in Italy now we have a dedicated program to CubeSats, and some of them are also for deep space. But the two missions I'm going to describe, they were part of a pioneering area when we start to mainly develop based on opportunities for flight. The first one, Argo-Moon, has been selected by NASA to take part in the Artemis 1 mission. At the time it was Exploration 1 mission. And it was one of the 13 secondary payloads that has been selected to accompany mainly the Orion capsule mission. And there were, over the 13, there were 10 from US, 2 from Japan, and 1 from Europe. And the European one was Argo-Moon, has been selected to test technologies for imaging in quasi-deep space and moon environment. And doing that, it will capture images, was supposed to capture images of the Orion itself, of the ICPS module, mainly. And also to confirm the separation of the other secondary payloads. In fact, it was one of the first that has been selected for, that has been, okay, I'm going to sit, that has been released at the first bus stop. Like this, it's easier. Well, this is, I'm not sure I will have time to describe in detail, but the timeline of mission was really challenging. It was supposed to be released and operated in a very few tenths of minutes. And it was supposed to have a first phase of orbiting around the ICPS, the SLS module that was the target for the imaging, and then to perform several orbital maneuvers in order to enter into a geocentric orbit with some flybys of the moon. The design was built around a 6U size CubeSat, basically, with two main payloads as optical payloads for the imaging, and then a set of subsystems. Some of them were components of the shell, some of them were developed to be really customized for this mission. But probably the real core of the mission was the software, the onboard software, because since, as I mentioned, the system need to have this capability of tracking the targets in an autonomous way. And so there's a software based on several layers of detection of the targets, and then guiding the targeting and the attitude control in order to maintain the targeting. After 6 years of development, the system was ready to be delivered to NASA, and it has been shipped, accepted, and then integrated into the Orion stage adapter together with the other companion for this mission. And they made this the preparation activities. You're probably aware that the SLS has been the first try happened the end of August, maybe, and yeah, where we were there hoping that it was the right one, but in fact this picture was before NASA scrapped the mission. Then my smile was not that good. And so after another couple of tries, in November, 16th of November, SLS left the pad, and after a few hours, Argo-Moon has been released as planned. Unfortunately, the system has been ejected, the CubeSat, with a tumbling rate a little bit in excess with what we were expecting. And in fact, the satellite, thank you, satellite entered in a safe mode for the first phase of the mission. So the capturing of the SLS images was not possible, unfortunately, but in the following phase, the satellite performed the mission with the orbital maneuvering and capturing pictures of the Earth with the 2 cameras and also of the Moon, with a quite interesting level of detail. But the real success was the testing of the software and the subsystems that were related to maneuvering and targeting. During the development in summer 2017, at the Italian embassy in Washington, where Greg Schmidt was there too, but now there was a ceremony for the signature of as Greg mentioned, ASI and Italy is one of the nodes for Survey International Partnership and Association, and after proposal and discussion, we agreed on collaboration, and so the chief scientists of the 2 agencies signed the agreement in the occasion of this meeting that was associated also to a technical discussion. I was there to present the small satellite that we were developing, including Argo Moon, and Andy Rifkin from the DART, from APL, presented the DART mission that was under development in the US for participating in the first planetary defense initiative. And during the cocktail after this meeting, the idea of proposing a small satellite to take part in DART has been discussed and then evaluated preliminary and then in detail. So we can confirm that it was feasible. The idea to have like a witness that will participate in the DART mission has been assessed. DART was the first, the planetary defense initiative, and is part of the AIDA larger initiative for planetary defense, again, where also the ERA mission will contribute in the next years. But LICIACube has been, which stands for Light Italian CubeSat for imaging of asteroid, has been talked to being a witness that can have a unique point of view, because can image the just released, like in this movie. It was carried by DART for 11 months and 12 millions of kilometers, and then has been released 15 days before that impact on the asteroid, with the purpose of being a unique local witness of the ejecta, in particular, that will be released from the Moon, from the asteroid surface, that will contribute in the main DART's objective. This was the mission profile that I just described, and has a scientific objectives that were related to the plume imaging in particular. And another unique capability was the one of passing during the flyby, image the not visible hemisphere of the asteroid, because DART was looking just one, of course, section, and from the Earth was the same, while LICIACube can have a unique point of view to give information about the what we call the shape model of the asteroid. So after that meeting, we built the cooperation that was behind this mission, including the Italian Space Agency, but also the national partners, the industry like Agrotech, and several other scientific partners that were mainly involved in the scientific assessment, but also in the orbital maneuvering, planning and designing, and also in the orbit determination navigation. The main, probably the main challenge was to define to have a very accurate navigation, Earth-based, and also to support the software with the machine learning in order to it be able to making an autonomous targeting during the very quick flyby. Because DART was very quick, of course, against the asteroid. It was flying at about 6 kilometers per second, and LiCiACube has almost the same velocity. So it was very quick and fast flyby. We were trying to have an accurate orbit determination. The team worked a lot with the US partner in order to define the best distance, the safest one, because we don't want to be impacted, of course, by the ejecta, but also have a good spatial resolution. So we identified 55 kilometers as a good target for this passing, and also the timeline of the 2 payloads on board was planned with a very high accuracy. Concerning the design, it was very similar to Argomoon, but with a very important customization. One was the payload. One of the 2 payloads was with the 3 filters. We also named the 2 payload and had a very intense testing phase that I cannot describe. And sorry, because as an engineer, this was the most exciting part. If you want, I can enter into details, but this was the last phase of testing and before the delivery to US and the integration into DART, which happened in the summer 2022. This is LiCiACube on one of the external panel of DART. This described the last few years of activities. And we had a very intense interaction with the US team, like 3 weekly meetings with the different teams and a lot of working together. And the LiCiACubers were basically part of the DART team. And the system, the 2 probes have been launched in November 2021. We had also a strong interaction to set the ground segment because we made use of these antennas for downlink for the communication, and yeah, these are how the 3 maneuvers were planned together with the 2 daily window for communication. So 15 days before the impact, so September 11 last year, LiCiACube separated successfully from DART, as for the previous video, but and DART had a successful impact on the Didymos surface after 15 days, and LiCiACube has been planned to pass 3 minutes after in order to have a plume very well developed in order to be imaged. And this is what happened after a few hours when the first pictures were downloaded to the Mission Control Center. And I'm very, very fast just to say that she's really happy. She's saying, "Oh my God." And I'm saying, "Can you please let me watch this?" And some other things that I cannot say because I left my seat in the front room to the ASI president, which was this guy, and you know, God bless him. And this is what we saw after we did the first picture that had been captured, and we kind of put together. There was a very high level of enthusiasm, as you can imagine, because the imaging was quite exciting. Very, very sorry, very sorry, very sorry. And it was direction. Okay, there was the night of the separation, I think, when they were trying to have what we call initial.
My goodness, 3, 2, 1. Wow.
Getting visual confirmation.
And after several hours, we started having.
Si vede che sono caduto. No. Wow, ragazzi, al centro.
There was a lot of interest after and during. I'm sorry, just to spoil. Just to go into the end, NASA confirmed that mission was successful. 32 minutes of delay in its orbit. DigiCube was very well recognized as a partner in front of Thomas Brook and I have to go. And yeah, and there are lots of papers under publication. Nature already accepted 5 of them. And in conclusion, it was a great success. And I'm happy to share with you.